Hi guys. Now in last class we have studied about in the conversion of units. This one is the application of dimensions. But right now here we will study about in the establishment of relation with various physical quantity. So this is our second point. So now the second one is in the establishment of a relation with various physical quantity. So quantities. Then now here there are number of factors on which the physical quantity that depends. So here we are seeing that there are number of factors. See, there is a number of factors on which the given physical quantity that depends. So we can understand this one by using an example. So suppose here we have taken an example, just example 1. Now I am going to take a pendulum. You know, a pendulum having its bob which is connected with a length either of string or wire or rod, whatever be there as per suitability. Okay, then just write down that suppose we have taken a pendulum whose mass of the bob say m, length of the pendulum just say L, and acceleration due to gravity say G. All these factors that depends. Okay, so all these factors that depends, but this one is the factor of time period. So here you can write, so let the time period of the pendulum that depends on all of the above factors, then calculate the time period. So here we have to find this time period, because the time period of the pendulum that depends on mass of the ball, length of the pendulum L, mass of the ball M, and acceleration due to gravity G. So we have to calculate the time period of the pendulum. So how we can calculate? It is very simple method. See here. Simply write down that the time period that depends on mass of the ball, length of the pendulum, and acceleration due to gravity. So you just take it m to the power a, l to the power b, and acceleration due to gravity having power c, and you just take it as equation 1. Then what you have to do, you just take dimensions on both sides. So after taking dimensions on both sides, what you will get, this one is your time period. So time period having dimension t, so t will be there. But for this one, m and l both should be 0, and this one is 1. So no need to write 1. Accordingly, this one is your mass m to the power a, this one is l, so l is length having dimension l to the power b. Now accordingly, this one is your acceleration due to gravity. So whatever the acceleration, you know the dimension of acceleration is lt minus 2, just like a simple acceleration in kinematics. So this one is lt minus 2 to the power c. Okay. Now m0 l0 t1, this one is equal to m to the power a, l to the power b is here, and l to the power c is there. That is L having B and C power. So this one is B plus C. Okay. B plus C is there. And now T to the power minus 2C only. So again, you have to equate these powers. So just write down that equating indices on both sides. You know the meaning of indices? Indices, that means power. Alright. So you can see m to the power a on right side. Now, consequently in left side m to the power 0, that means a is equal to 0. So just write down a is equal to 0. This one is your next equation, equation 2. Accordingly, you just take t. This one is minus 2c is equal to, here t raised minus 2c, but here t raised 1. That means minus 2c is equal to 1 with there. So how much we see? So C will be minus half. Next equation. And then you calculate this L to the power BC. That means B plus C is equal to how much will there? L to the power 0. So this one is 0. And now put the value of C from equation 3. So B plus minus minus half is equal to 0. So B is equal to how much? Plus half. Next equation. Okay. Then from this equation, equation 1, equation 2, 3 and 4, you just put the value of A, B, C from equation 2, 3 and 4 in equation 1. So just write down from equation first, second, third and last one is 4. So what you will get from here, that this T proportional right now, m to the power a, so a to the power 0, that is m to the power 0. Now there is L to the power b, and b is equal to how much? Plus half, that is 1 by 2, and there is g to the power c, and c is equal to minus half. So this one is minus half. Now after doing calculation, from here you will get anything having power 0, that will be 1, and the product of 1 will be, that is L to the power half and G to the power half. So you can write down from here that T proportional to L by G, because this one is negative, so that will come in numerator, because both having power half, so replace half by this root. And then you have to replace this proportionality constant. So a constant will be there, you just suppose k be there, so k times L by G. But dimensions having a drawback, that it will not calculate the constant part. We will discuss about it later on. So just see, but we know about its value. This one is 2 pi. So right now here I am going to put the value of k constant. This one is 2 pi root under L by G. So using this relation, establishment relation with various factors, you can calculate the equation. Okay, but for this calculation, you should know that your physical quantity, that is time period, that depends on other various physical quantity. You should know this one. Okay. Now from here, we can also take another example, just like about frequency and whatever you want as per your requirement. You can take even force and what you want. So you suppose if I wanted to here find out about frequency, so how you can find that frequency? So to find that frequency, first of all you should know that this frequency is depends on other factors. So which one is the factors? So you have to find out, or you have to grasp that factors first. So see, I am writing here that like that. Next example, suppose example 2. If the frequency of a stressed string that depends on the length of the string, the mass per unit length of the string, let it be mu, and the length of the string, you just suppose this one is L, and the tension actually tension it is represented by T, so the tension T on the string. So how you can compute this one? This is very simple. First of all, you just make a concept. Concept is that there is a string. This one is a string. Alright. So if this one is a string and this one is a string that is connected with two wall, vertical wall, and whatever two support will be there. Suppose A and B is the two support. Okay. So from here, what you are seeing is that this one is your string. If this string having length L, so your frequency depends on this length L. When it will vibrate, then this length having some mass, so its mass per unit length, you can see here that mass per unit length that depends on it also. So that is mu will be the mass per unit length. Simple. This one is mass per unit length. And now after being vibration, a tension will develop in the string, that is inside the string. So that is T. T is the tension. Tension is a force. Alright? Okay. And there is a two support, you just represent this one by A and B. A and B. So now, accordingly, according to this question, that your frequency is simply represented by small f or mu. So this one is the way of representation. So that depends on length of the string, that is L, mass per unit length of the string, that is mu, and a tension, that is T. So you just suppose this one having on its power, on its this physical quantity A, B and C, and let it be equation 1. Then what you have to take, that you have to take dimensions on both sides. So after taking dimensions on both sides, you know the frequency having dimensions T minus 1. So frequency having dimension T minus 1. So M0, L0. Alright. And then this one is proportional. L, dimensionally L having power A. Mu, this one is mass per unit length. Okay. So mu, this one is mass per unit length. That is mass by length. So mass having dimension M and length having dimension L. So add to the power minus 1, and this one having power B. And this is your T, that is tension force, dimensionally MLT minus 2. It is written as, and this having power c. Now this one is same, m0 l0 t raised minus 1 proportional m to the power how much, m to the power b, and from here m to the power c, that means m to the power b plus c. Now just take l. So how much with the power on l? So l to the power a from here, l to the power minus b from here, and l to the power c from here. So l to the power a minus b and plus c. Consequently, you have left t. So t to the power how much will be there? So you can see that t to the power t only be here. So minus 2 into c, that is minus 2c. So t to the power minus 2c only. And then now equating indices on both sides. Alright. So this on both sides. So minus 2c is equal to minus 1. From here minus and minus will be cancelled. So c is equal to how much? Half. So c is equal to half will be here. And because this one is equation 1, so this one is second equation. Now again, then from here b plus c. Now b plus c is equal to how much? This one is equal to 0 because m plus this one and m is 0. So this one is 0. Then put the value of c from this equation to this one is b plus half is equal to 0. Then your b will be minus half. Next equation, third. And then you take this one from here. So a minus b plus c, a minus b plus c, l to the power, here is 0. Then put the value of b and c from equation second and third. So b is equal to minus half and minus b there, so minus minus plus half will be there. There is a plus c, but c is equal to plus half. So no issue, there will be plus half is equal to 0. From here half and half is equal to 1. On right side minus 1. So this one is your which equation? Equation 4 will be here. Then from equation number 1, number 2, number 3 and number 4, what happens? First one is there that your frequency f proportional a to the power l to the power a. So l to the power a, how much be a? Here minus 1. Second one is mu to the power b. Where is your b? B is equal to half from this equation, minus half from equation 3. So minus half will be there. And now the last factor is T, where T is tension force. T is C, and you see from this equation half. So put there half. So what you are getting from here, that your frequency that proportional to T by mu of root and L will be there -1. So you just take it outside 1 by L. This one is just like this L. Okay. And then F is equal to, you just replace this constant. So one constant, you just replace this proportionality constant. So after being replacing this a constant with here. So this one is suppose k by L. So k by L will be here of root t by mu. So now here you are seeing, and what you are seeing, you are seeing that one constant k is there also. Okay, which is not defined by dimensionally. So this one is a drawback, we will study later. Now this one is the magnitude of k that is given experimentally. So we can write there that this one is half. So 1 by 2L of root t by mu. Alright, so this one is your result. So you can take either this one or